Okay, good morning. So let us, as usual on Mondays, start solving the problems from homework number 3 now. So let us read the first problem together here. Let n be a natural number and let d be the greatest common divisor of 5n plus 3 and 9n plus 4. The largest value of d is equal to, we are supposed to find the largest value and put it here. Okay, so the numbers that I have are 5n plus 3. N is an arbitrary natural number, and the other one is 9n plus 4. I want to look for the greatest common divisor of these two numbers. I want to see what is the largest possible value for this GCD if n is an arbitrary but not pre-assigned number. Okay, so I don't know what that is, so I call it D, and I want to find D. Because D is supposed to be the common divisor, it means that D divides 5n plus 3. D also divides 9n plus 4. Yes? So what is the meaning of this? It means that there exists a q, an integer q, such that the number on the right is equal to the number on the left multiplied by that q. In other words, this number is a multiple of d. And for this one, there exists probably a different integer, which I call it q prime, so that the number on the right is equal to that d multiplied by q prime. So if you remember from what we had in the lesson, one idea is to get rid of this n. To get rid of this n, I want to make the coefficients of n the same but opposite, so when I add them up, the n is gone. So what I will do, I will multiply the first one by, say, 9. So 9 times 5 is 45n, and then 9 times 3 is 27, and on the right-hand side, I will have 9d times q. And here, I will multiply it by minus 5, so this becomes minus 45n. Minus 5 times 4 is minus 20, and it becomes minus 5dq prime. And now what I will do, I will add them side by side. Minus 45 and 45 are gone. 27 minus 20 is 7. And on the right-hand side, I will have 9dq minus 5dq prime, yes? But immediately it becomes clear that I can factor a d out. So 7 becomes d times 9q minus d minus 5q prime. Okay, but q and q prime are integers. 9 and 5 are also integers, so this combination is definitely an integer. So I can call it capital Q, and I'm sure that the capital Q belongs to z. So what I understand that 7 is d times q, and q is an integer. So this means d divides 7. Yes? So it means that 7 is divisible by d. There are only 4 numbers, so that 7 is divisible by plus or minus 1, plus or minus 7. So d is either one of these numbers, but the problem is that by definition d is a natural number. The greatest common divisor is by definition a natural number. So minus 1 and minus 7 cannot work. So this means that I have only 2 options. Because d belongs to n, d is either 1 or 7. Okay? Of course, at this step, you might say that the maximum possible value for d as wanted in the problem is 7, and the answer is correct. But I want you to understand that it is a little bit fast to draw the conclusion that the maximum possible value of d is 7. Because look at the logic. The logic tells you that if this number is d, then there are 2 options available for d. Either d is 1 or d is 7. But it does not tell you that these numbers are indeed realizable. So to guarantee that 7 is really realizable, you have to bring an example to make sure that sometimes it really becomes 7. Because again, let me repeat, if this is D, D is either 1 or 7. But it does not guarantee that 7 or 1 indeed realize, yes? So how should I know that? I have to bring examples. For example, if I choose n to be 1, then the other one is 5 times 1 plus 3 and 9 times 1 plus 4, which is 8 and 13. So this is GCD of 8 and 13. Of course, this is 1. So yes, 1 is indeed realizable because, for example, when I choose n to be 1, I will get that one. But I should also make sure that 7 is indeed realizable. How I do that? So, for example, I have to bring an example. For example, let me choose n to be, I don't know, 5. I want to make sure that this works. If I put 5 there instead of n, then it becomes GCD of 25 plus 3, 28, and then 49. So the GCD between 28 and 49 is the biggest number, so that 28 and 49 are divisible by. It is easy to see that that number is 7. So indeed, yes, both 1 and 7 can indeed realize. So then I am looking for the maximum, so the maximum is definitely 7. But that is a crucial part, okay? But I want you to understand the first part of the problem is indeed necessary because how many choices I have for the potentially infinitely many. But this calculation shows that no, there are only at most 2 options. One of them is 1, one of them is 7. The point is that I want to see that 7 is indeed possible, and I gave an example, for example, n equals to 5, and I realized that yes, d equals to 7 is indeed possible, but there are no other options. Either it should be 1 or 7, and 7 is possible, so the maximum is 7. Now let us go to the next problem. Let A and B be co-prime natural numbers. Co-prime means that GCD between A and B is indeed equal to 1. If C is a natural number such that C divides A plus B, then the greatest common divisor of A and C is what? We want to find the greatest common divisor of A and C if we know that A and B are co-prime and C divides A plus B. So let us go to the board. So the information that I have is this. I know GCD of A and B is equal to 1. Why? Because it is mentioned in the problem that they are co-prime. Co-prime means exactly this. 2 numbers are called co-prime if the GCD between them is indeed 1. And we have another assumption that C divides A plus B. Now my goal is to find GCD of A and C. This is wanted. Okay, what I do, I'm looking for this question mark. So if you don't mind, let us give it a name. Let me call it D, and then I want to find D. Okay, I start from here. C divides A plus B. What does this mean? This means that there exists a Q in Z such that the right-hand side, A plus B, is C, the left-hand side, C, multiplied by that Q. This is the first thing that I can know from this assumption. But I am assuming that the GCD of A and C is D. So GCD of A and C, I called it D. So this means D divides A and D divides C. And this symbol I'm using means and. D divides C. Okay. But what I want to do, from D divides A, I can see that there exists, let me choose a different letter. For example, there exists a T in Z so that the number on the right is the number on the left times that T. Because D also divides C, then it means that there exists another number, so let me call it T prime, in Z such that the number on the right, C, is the number on the left, D, times that T prime. Yes? And now what happens if I, instead of A and instead of C, here in this equation, I put D times T and d times t prime. So let me put them back here. So what do I get from this equation? Instead of a, I have d times t, b, I'll copy and paste, but on the right-hand side, I will write d times t prime, but multiplied by q. Okay, so what happens, I keep b on the left, and I move this to the other side. So it becomes d times t prime times q minus d times t. But between these two, I can factor a d out. So then it becomes t prime times q minus t. But this number is definitely an integer because t, t prime, and q are all integers. So this combination is an integer. So I can call it a capital Q, which belongs to z. So what does it mean? It means b is equal to d times q, and q is an integer. So this means that d divides b. Okay? But now look, d divides a. Using this argument, I also realize d divides b. So let me write it here. So what I know that d divides a. I now showed that d also divides b. So what does it mean? It means d is a common divisor. So d is a common divisor, but GCD of a and b is the greatest common divisor. Okay? D is a common divisor because it divides A and B simultaneously, so it is a common divisor, but GCD is the greatest common divisor. So what does it mean? It means D, which is a common divisor, it should be at most equal to the greatest common divisor. Yes? This is logical, yes? The greatest common divisor, a common divisor. Any common divisor is less than or equal to the greatest common divisor. But look, the problem tells you that the greatest common divisor between a and b is 1. So this number is just 1. So I realize the d that I am looking for is less than or equal to 1. But what is d? D was the name I gave to GCD of A and C. So D should be a natural number. So D is a natural number. On the other hand, it is less than or equal to 1. So this means that D has to be equal to 1. So this means that the GCD of A and C that I was looking for is just simply 1. And that is the answer that you have to provide here for this problem. Okay? So now let us go to the next problem. If p is a prime number greater than 5, then what is the sum of GCD of p cubed of 300 plus, what is the sum of GCD of p3 and 300 and LCM of p3 and 300? So we want to calculate this. The calculation will give me one of these options and I want to choose it. But that is also very simple because you see, let me write. So p is a prime. P is greater than 5. And then I want to know GCD of p cubed and 300 plus least common multiple of p3 and 300. Okay, so what should I do? I can prime factorize 300. So 300 is just 3 times 10 to power 2, but 10 is 2 times 5 to power 2. So then it becomes 2 to power 2 times 3 times 5 to power 2. Of course, if you don't like it, you can just simply write 300 and then divide it by 2, 150, and then continue and then until you reach to 1. But this is faster. Okay, now if I want to find GCD, I also have to factorize p cubed. But p cubed itself is in the factorized form because it is mentioned that p is a prime number. So the factorization of p cubed is p cubed itself. And if I want to find GCD between these two, what I'm supposed to do, I am supposed to write the common factors in my factorizations with the lowest exponent for each factor. The factors that appear in this are just 2, 3, and 5, and the factors that appear for p cubed is just p. But I see that because P is a prime factor greater than 5, there is nothing in common. So then it means GCD is equal to 1. But what is LCM? LCM of P cubed and 300, do you remember? Is is all factors common or uncommon? So it means 2, 3, 5, and P, but this time with the highest exponent. So here, but be careful, P is a prime number greater than 5, so it means that if I want to see what is the highest power of 2, I have to only look here because there is no chance that I can find a 2 here, or a 3 here, or a 5 here. So the highest power is 2, the highest power for 3 is 1, the highest power for 5 is 2. So this is my LCM, but this is nothing except the number 300. So this becomes just 3, oh, but sorry, I also have to put a power of 3 here because I told you that I have to choose the factors with the highest exponent. The exponent that appears for P cubed is 3, the highest one. So then it becomes 300 P cubed. So the question mark is GCD, which is 1, plus LCM, which is 300 P cubed. Yes? And that is which option? Yes, that is this option that you see here. Okay, any questions? Good.